Hello dear students. Today let us learn some of the problems to find velocity and acceleration in both spatial and material form. Let us take up the first problem. Let us read the problem. The problem they have given velocity v is gradient phi, where phi is a scalar function, that is v is irrotational. That's the meaning of that. Okay. Then we have to show that or prove that dv by dt, that is acceleration in the material form, is equal to gradient of dou phi by dou t plus v square by 2. This is what we have to prove. And hence, so after proving this, we should also prove that the acceleration is irrotational. Okay. Yes. So what is given, we'll write down. So they have given v is gradient phi, fine. And we have to prove that dv by dt. We have to prove dv by dt is this. That is, we have to prove this. So we should write the relation between material acceleration and spatial acceleration. That is this. Look, this is the material acceleration, and this part is the spatial acceleration or local acceleration, right? The relationship between them. So plus gradient v square by 2 plus vorticity cross velocity. This we have proved in the last class. Let us call this as equation 1. Okay, where v is velocity and omega is the vorticity. Omega is nothing but curl of v, vorticity, right? Okay. So now what they have given? They have given v is gradient phi, no? So we'll find what is omega. So what is omega? Omega is gradient phi, right? So omega is nothing but curl of v. V is nothing but gradient phi, and we know that curl of grad is 0. So omega is 0. Now, so omega is 0, no? Substitute in 1. So using omega equal to 0 in 1 is becoming what? So 1 becomes dv by dt as it is equal to dou v by dou t plus gradient of v square by 2. Since omega is 0, the third component, the third term on the RHS will become 0. Okay, and also v is gradient of phi. So again we'll put in the place of v. In this equation we'll put in the place of v gradient phi. In the place of v gradient, everything is same. In the place of v, the vector v, we are putting gradient of phi. And for this v, we are not, v square, we are not putting anything. V square is a scalar, right? Okay. So now, so gradient of phi. Now what we do is, we'll take gradient outside, right? So when you take this gradient outside, so what is going to happen? I can take this gradient outside and dou by dou t inside. So gradient of dou phi by dou t it will become, right? And here also gradient, and there is gradient here also. So we can take that gradient outside, still outside. So gradient of dou phi by dou t plus v square by 2 as it is. And this is what we had to prove, and we proved this. So the first part of the solution, the problem we have proved. For the second part, so what is the second part we have to prove? We have to prove that the acceleration is irrotational. And what is our LHS? This LHS is nothing but acceleration. Okay, we have to prove acceleration is irrotational, no? So we'll take curl on this to show that acceleration is irrotational. This you have to complete it. It is irrotational. Is irrotational. Is irrotational. We have to prove acceleration is irrotational. Okay. So A equal to the previously we have got acceleration in material form, no? So we have just written that as A. So A is equal to gradient of dou phi by dou t plus v square by 2. That is by the previous step. Take curl on this. We'll take curl on this, right? So curl of this A, and that is nothing but curl of gradient of this, and we know that curl grad is 0, so it is 0. So we got curl A is 0, therefore A is irrotational. That means acceleration is irrotational. Hence the solution. The problem 1 is over. We shall go to the next problem. The next problem is this. So let us read the problem. So for a material body in motion, they have given displacement. Displacement field is given by this u1, u2 and u3. Okay. So u1 is 0, u2 is in terms of xi's and there is also t, right? And u3 is in terms of xi's and we have e power t, that is in terms of t. So xi and t. Okay. We have to find what? We have to find velocity and acceleration in both the material and spatial forms. Fine. So they have given displacements. We have to find velocity and acceleration both in material and spatial form. Okay. The given displacement field is in which form? So we have on the RHS we have xi's. There is x2, x3, and also t is there, right? Fine. So it is in terms of xi and t, right? So it is in the spatial form. It is in the spatial form. The given displacement field is in the spatial form. Okay. So u1 is 0, u2 is this, and u3 is this. We'll call that whole thing as equation 1. Whatever displacement given in terms of spatial form, we have just called it as equation 1. Now, to find the motion in the spatial form, let us find the motion in the spatial form. Okay. They have given displacement in the spatial form. Let us find the motion in the spatial form. Oh. What is ui? Displacement is nothing but xi minus xi naught. I equal to 1 to 3. Correct? So what is u1? u1 is x1 minus x1 naught. u2 is x2 minus x2 naught. And u3 is x3 minus x3 naught. Fine? So we'll call this as 2. So substituting 2 in equation 1. So this is our equation 1. So what is u1? u1 is x1 minus x naught equal to 0. Equal to 0. Okay, we'll substitute in the equation 1. So tell me now. So in 1, so it is becoming what? First equation of 1. So you have u1 equal to 0, no? So u1 is x1 minus x1 naught equal to 0. That implies x1 naught equal to x1. Right? Now, second equation of equation 1, that is u2. What is our u2? u2 is x2 minus x2 naught. So we'll take x2 minus x2 naught. The remaining as it is. Simplify that. So x2 will get cancelled. So we have minus x2 naught equal to this. Change the sign throughout. So you get x2 naught equal to this. Fine. Okay. Call that as 4. Similarly, take equation, third equation. Take u3. u3 is x3 minus x3 naught. The remaining as it is. And we can easily see that x3 and x3 will get cancelled. And change the sign throughout. So you get x3 not equal to this. That is, call it as equation 5. So 5, 4 and 3. These are representations of the motion in what form? Spatial form. Or you can also call local. So once we have the motion in the spatial form, it is very easy to find the velocity in the spatial form. So what we have to do? We have to just differentiate with xi fixed. With xi fixed. Okay. So what is v1 naught? v1 naught is nothing but, so we'll not take this. This is wrong actually. We put it in red. So this is wrong, not this. So that is this one. The correct one is this. So dou x1 naught by dou t, what is fixed? xi is fixed. Xi is fixed. That is v1 naught. First component of the velocity in spatial form. So what we have to do? We have to take x1 naught. We have to take x1 naught and differentiate with respect to t. What is fixed? xi is fixed. xy is fixed. So where is x1 naught? x1 naught is where we look at equation 3. So here is x1 naught. Here is x1 naught, correct? Here is x1 naught. So we'll take that. So what I have to do now? I have to differentiate this with respect to t. X1 equal to x1 naught. I have to differentiate this. We'll differentiate. What is fixed? Xi is fixed. That means only xi here is x1 we have. And we have to fix that. We have to differentiate with respect to t. There's no t in this equation. So differentiation of x1 with respect to t is 0. Is 0. So therefore, v1 is 0. First component of velocity v1 is 0. Okay, we'll go to v2. We'll go to v2. So what is v2? So dou x2 naught by dou t. What is fixed? Xi is fixed. Xi is fixed. Okay, this notation I should not write. So this is correct. Green one is correct. So next what we have, that is equal to, now go to x2 naught. So x2 naught comes in which equation? We'll look at the equation. We'll look at the equation. We'll look at the equation. So x2 naught equal, that is equation 4. Here we have, right? This is x2 naught. Okay. So here x2 naught. We have to differentiate this with respect to t. What is fixed? Xi is fixed. That means x2 is fixed. X2 should be treated as constant, and x3 should be treated as constant. Then there is x2 here and there is x3 there. So xi's must be treated as constants, and we have to differentiate with respect to t. Okay, yes. So differentiate that. That is our v2. So that's here. So x2, x3 remain the same, and only we are differentiating e powers. Okay, whenever minus is there, minus will come, of course, here. So this is equation 7. And velocity, the third component. Third component is, this one. This is wrong, so I'll not write this. So that this green one will be correct. That is this. Dou x3 by dou t, xi is fixed. Similarly, take x3, that is equation 5. Okay, and differentiate that with respect to t. What is fixed? Xi is fixed. And we get that is equation 8. So equation 6, 7, and 8. These are nothing but the velocity in the spatial form. Okay. Now, once we have the velocity in spatial form, it is very easy to find the acceleration in spatial form. That means what? Differentiate with respect to t. What is fixed? Xi is fixed. Xi is fixed. So again, take v1 naught. What is v1 naught? V1 naught is 0. So differentiate that with respect to t. There is no t there. It is 0. So a1 naught is 0. Similarly, a2 naught. What is a2 naught? Take v2 naught. That is equation 7. Right? Xi is x2, x3, and x2 minus x3. It's constant. Only thing is we have to differentiate with respect to t. Right? So differentiate with respect to t. This is our a2 naught. And similarly take v3 and differentiate with respect to t with xi fixed, and that is nothing but equation 11. So equations 9, 10, 11 are acceleration, right, in the spatial form. So we finished velocity and acceleration in spatial form. Now we have to obtain the acceleration and the velocity in the material form. Now to get the material form, we have to have the motion in the material form. So let us find the motion in the material form. Now, what they have given, we had given displacement in the spatial form, remember, and we converted that into spatial form using displacement relation, right? Okay. So now I've got the motion in the spatial form. So we'll call them as 3, 4, 5. You can give whatever numbers you want. Okay. We are just giving it as 3, 4, 5. So now what we do is we'll solve these equations for xi's in terms of xi naughts, in terms of material coordinates. Okay. So equation 3, I can just write down x1 in terms of x1 naught. Just reverse this. Okay. Call it as equation, some equation, whatever it is. So next, add 4 and 5. Adding 4 and 5, what is happening? So when you add these two, you're going to get this. Okay. And simplify. So xi is in terms of xi naughts. Okay. What is happening this to this e power minus t? It has come here as e power t. Then again subtract 4 minus 5. You get this. We'll subtract 4 minus 5. We get this. And again, this e power t was there. No, we'll just shift that side. So you're going to get xi is in terms of xi naughts and t. Now we have got these two equations. No, this and this. So adding this and subtracting the above two equations. So by adding, what are we getting? By adding, I'm getting x2 in terms of xi naughts and t. And subtracting, no, I'm getting x3 in terms of xi naughts and t. Right? Call them as 13 and 14. So these equations 12, 13 and 14 represent the motion in the material form. Right? So 12, look at 12. 12 is x1 in terms of xi naughts, x2 in terms of xi naughts, and x3 in terms of xi naughts, and of course t. Right? So once we have the motion in the material form, we can easily find the motion in the velocity in the material form and acceleration in the material form. Okay? Now we'll find the velocity in the material form. So what are we going to do? So material form is nothing but we are going to differentiate, right, the xi with respect to t with what coordinates fixed? With the material coordinates fixed, that is xi naughts fixed. So Vi is this, that is dou xi by dou t, xi naughts fixed. I equal to 1, 2, 3. So take V1. V1 is dou x1 by dou t, xi naughts fixed. So take x1, differentiate with respect to t, right? What is our x1? Look at x1. X1 is nothing but equation 12. What is equation 12? Equation 12 is this. Equation 12 is this. Okay. So we have differentiate this with respect to t, xi naughts fixed. So there's no t at all here. So it is the differentiation V1 will become 0. Now go to V2. V2 is nothing but, what is V2? Dou x2 by dou t, xi naughts fixed. So look at x2, that is equation 13. So we have equation 13, that is this. Okay, that is this. So differentiate this with respect to t with xi naughts constants. So x2 naught, x3 naught, x2 naught, and x3 naught, they're all constants. Differentiate with respect to t. Okay, so we get that V2 equal to this whole thing. Similarly, V3. So take, x3, differentiate with respect to t with xi naughts fixed and call it as equation 17. So 15, 16, 17 are components of velocity in what form? Material form. Now, when we have the material form velocity, we can easily find the acceleration in the material form. So AI is nothing but dv by dt, dou Vi by dou t with what fixed? Xi naughts fixed. I equal to 1, 2, 3. So what is A1 now? Take V1. So what is V1? V1 15. V1 is 0. V1 is 0. So what is A1 now? Dou V1 by dou t with xi naughts fixed. Since V1 is 0, it is 0. Call it as AT. Now what is A2? Dou V2 by dou t with xi naughts fixed. So look at V2. So V2 is given by equation 16. So this is our 16, right? This is our V2. So what we are going to do in this? So xi is, we have to xi naughts, we have to keep constant and differentiate with respect to t. That is our A2. Similarly, A3 is nothing but dou V3 by dou t with xi naughts fixed. And that is nothing but this, call it as 20. So equations 18, 19, 20 are nothing but the components of acceleration in the material form. In the material form, right? As simple as that. So this problem 2 is also over, and we have some assignments for you people. You can easily find, these three, solve these three assignments. Find velocity and acceleration in both material and spatial form for this motion. Similarly, problem 4 and problem 5. Okay, I hope you try these things. Fine. So let us stop now. See you.